Okay, now we're going to look at infinite geometric series. We have this triangle. When we look at the area here of all of these black triangles in the middle, they continue, right? Triangles inside of triangles inside of triangles, they continue infinitely. The black triangles are an infinite series, but they have a sum. And an infinite series can have a sum when you continue to add something smaller every time. If you look at that, can you tell me what fraction of the overall triangle these black triangles are? Do you see that it's 1/3 of the entire triangle? So we have our gray, we have our black, we have our white triangles. So the black make up 1/3. So even if infinitely I'm drawing more triangles inside the little triangles infinitely, they're going to add up to 1/3 of the overall triangle. So this is the idea. It's kind of a visual way of understanding that there is a sum for some infinite geometric series. And that is when your R is less than 1. So an infinite geometric series has an infinite number of terms. It's a geometric series. A arithmetic series that's infinite will not have a sum because you're just adding or subtracting over and over again. But if we are dividing by 3, dividing by 3, dividing by 3, or multiplying by 1/3, multiplying by 1/3, it continues to get smaller and smaller and smaller. So an infinite series that has a sum is called convergent, and it has a sum if the absolute value of R, whether it's positive or negative, is less than 1. If it is greater than or equal to 1, if R is greater than or equal to 1, positive or negative doesn't matter, that's where we have absolute value there, it does not have a sum and it's called divergent. Now the sum formula for an infinite geometric series is really easy. It's probably the easiest formula we have. It's A1 divided by 1 minus R. As long as R is between -1 and 1 and not 0. 0 is not going to give you anything. So let's look at a couple of infinite geometric series. One of the clues that it's infinite is the infinity symbol on top of your summation notation. Another one is it gives you the ... and doesn't tell you to how many terms. It wants you to find the sum. Okay, so those are the two things you're looking for. If it gives you the ... and doesn't say find the sum of the 20 terms, then it's actually asking you to find the sum of the infinite series. So we're going to identify our A1 and our R. That's all we need. My A1 in this case, this is in the form A1 times R to the n minus 1. So my A1 is 5. And if I plugged in the 1 here, I get 1/2 to the 0, which is 1 times 5 gives me the 5. And my R is the 1/2. 1/2 is less than 1, so this should have a sum. The sum formula is A1 divided by 1 minus R. So divided by 1 minus 1/2. And 5 divided by 1/2 is 10. So the sum is 10. Think of 5 candy bars and you're dividing them all into halves. That would give you 10 pieces. Also, multiply by the reciprocal. The reciprocal of 1/2 is 2. 5 times 2 is 10. So can you do this problem here? This is your problem. Can you tell me the sum of this infinite geometric series? Identify your A1. Identify your R. Plug it into the equation. Don't unpause it until you have an answer. Okay, you should be done doing this by yourself before you watch me do it. My A1 is 2, because of the 2 times 1/3 to the 1 minus 1, that's going to give me 2. And my R is the 1/3. So a1, 2 over 1 minus r divided by 1 minus 1/3. That's 2 over 2/3. 1 minus 1/3 is 2/3. Multiply by the reciprocal times 3 over 2. The 2's cancel, and we get 3 for our sum. So remember, to divide fractions, you multiply by the reciprocal. Are you stuck on the 1 minus 1/3? If you had a piece of pie, or a pie, and you ate 1/3 of it, there would be 2/3 left. Okay? Or you can always make that a fraction with a common denominator, 3 over 3. Now let's look at the next ones where we have to find what, r. We know a1 is negative 4/3. What is my r? Let's look at negative 12 divided by 4 and 36 divided by negative 12. These are all negative 3, negative 3. So I have a common ratio. That ratio is not less than 1. So this is divergent, and there is no sum. Be very careful with infinite series to make sure that you check to make sure r is less than 1. All right, look at the next one. Give it a try. Identify your a1 and your r. Pause it before you watch me do it. Okay, you should have already done it. a1 is negative 5/2. r, negative 10 over 5. 20 over negative 10. Negative 40 over negative 2. r is equal to negative 40 over positive 20, sorry. r is equal to negative 2. Negative 2 is not less than 1. The absolute value of negative 2. Remember that the negative sign doesn't affect whether it's divergent or convergent. It's just the value of the number. So this is divergent, and there is no sum. Okay, that should be the easiest problem on the test, where you look at r. It's asking for you an infinite sum, and it's greater than 1. Okay, the last two, 3 plus 3/2 plus 3/4. To find r, we're going to do 3/2 divided by 3 over 1. Make it a whole number. 3/2 times the reciprocal 1/3. The 3's cancel. R is 1/2. So r is less than 1, so it's convergent. It should have a sum. a1 is 3. So I have 3 over 1 minus 1/2. 3 divided by 1/2. 3 divided by 1/2 is 6. All right, multiply by the reciprocal. 3 times 2 over 1. All right, think of 3 pies, dividing them all in half. I have 6 pieces. Go ahead and try the next one. 5 plus 5/2 plus 5/4 plus 5/8. Identify your r. Identify your a1. Pause it. Find your sum, if there is one. Okay, you should have done it already. a1 is 5. r is 5/2 divided by 5 over 1. 5/2 times 1/5, also 1/2, which is less than 1. So we have a sum. So 5, a1 over 1 minus r. 5 divided by 1/2 is 10. And that is your infinite geometric series.